So, welcome to my presentation about the paper Venus's Spectral Signatures and the Potential for Life in the Clouds. This paper was written by Sinjay S. Limaye, Rakesh Modul, David J. Smith, Arif H. Ansari, Gregorets P. Slovic, and Parag Aishapayan. I hope I pronounced all their names right, but I highly doubt it. So, why did I choose this paper, and why do I think is this paper important for astrobiology? So, I think Venus often gets overlooked as a potential habitat for life. So we always talk about Mars, Europa, etc. But Venus kind of gets forgotten a lot. And I think in this paper they give quite an in-depth explanation, or they give possible also metabolic pathways how there could life exist. So now to a short overview of my presentation. In the first part, I want to do a short introduction. What are these spectral features? What can you expect of this presentation? Then in the second part, I want to shortly touch on planet Venus itself, give you just some facts as a factual overview, and then we're also going to look a little more into the Venusian atmosphere. And then in the next part, we're going to talk about these spectral features, the contrast in the UV spectrum, and also how this could actually be explained. Then in the next part, we're going to talk about the possible life in Venus's clouds. So could there be life? And if so, could it contribute to these spectral features that we're going to talk about later? Then how could it actually survive? What are some possible, or what is a possible metabolic pathway? And we're also going to look at a terrestrial microorganism called a ferrooxidans, which they use as an example in the paper, which I think it's quite interesting to use as an analog for possible life on Venus. Then we're also going to talk about how these microorganisms actually ended up in the clouds. So how did they get transported there, or could they actually get evolve on the surface and then got transported to the clouds? In the last part, I want to talk about future studies, so what they actually propose in this paper, and also give my short personal opinion about the paper. And then in the end, I'll make a short summary of what we talked about in this, or what I talked about basically in this presentation. So first, to a short introduction. There are actual changes in contrasts and albedo of Venus between 330 and 500 nanometers, so in the UV spectrum, and they cannot be fully explained so far. So they argue that there might be potential life there, which could explain these contrasts and albedo differences. They argue that there are favorable chemical and physical conditions, such as the presence of water, sulfur compounds, and carbon dioxide, which are known to be used in metabolic pathways here on Earth of some organisms, and that there are also moderate temperatures and pressures, which at first hearing you might think, well, Venus is very hot, which it is, but in the next part we're going to look at some possible areas where the temperatures aren't as high and where life could actually exist as we know it. Then they argue they present the possibility that terrestrial organisms could survive on Venus, and as I already said, that they can contribute to these spectral features that we're going to talk about in a second. So now to planet Venus itself. Here you can see a picture of it in the visible spectrum, and here on the first slide you can see it in the UV spectrum, where you can already see that it looks quite different and not as homogeneous as in the visible spectrum. So Venus is about 1.7 astronomical units away from the Sun. So, and as most of you probably know, 1 AU is corresponds to the distance from here, from Earth to the Sun. Then 1 year on Venus is about 117 days. And Venus has a very similar composition to Earth. It also has around the same mass, so actually quite similar, even if you compare it to a planet like Mars, because much smaller and a little different composition. So the atmosphere of Venus is very thick, and it's mainly made up of CO2, so carbon dioxide. The pressure on the surface is around 92 atmosphere, so 92 times the pressure here on Earth, also at sea level, and the temperature is around 460 degrees Celsius, which is very high, and some of you or a lot of you may know that most known organisms can survive above 120 degrees. So how could actual terrestrial microorganisms survive there? So for this we have to look at Venus' atmosphere. Here these two graphs are from the paper which I read. On the x-axis you can see the temperature, and on the y-axis you can see the pressure in millibar, and 1,000 millibar corresponds to 1 atmosphere. And here you can see the altitude. So as I mentioned, or as I said before, 1 atmosphere is the pressure here on Earth, and if we look at this diagram, you can see it corresponds to about 60 degrees. And so now we have this 60 degrees, and we look in this right graph, and we can see that it's about 60 degrees Celsius at around a height of 50 kilometers. Also, so at an altitude of 50 kilometers. So you can already see that there are very much favorable conditions or possible conditions for life to exist, because here on Earth we also have this kind of temperatures. So there's already this possibility. So in the next part I want to talk about Venus's spectral features. In the first part about the contrast in the UV spectrum. So there are these differences in albedo across different wavelengths. And here in A and B, in these two pictures, you can see it's very heterogeneous, and you can see quite a lot of differences in absorbance, right? But if you look at, for example, C, which is in the visible spectrum, you can already see that there is that is way more homogeneous, and also from D to H, which is in the IR spectrum, you can see it's mostly homogeneous, and you can't really make out differences. And if we compare this to Earth here on the bottom, from I to N, we can't really see differences in absorbance between the different wavelengths, right? So it's quite always the same. So very different from Venus here, because it changes very drastically. So this was actually already discovered in 1928, so almost 100 years ago, but to this day there's still no full explanation for this. So, but what how do scientists try to explain this contrast? So sulfur dioxide variations in the atmosphere of Venus could partly explain these differences, but still not fully. And also detected FeCl3 in the atmosphere of Venus could also provide an absorber for this phenomenon. So FeCl3 is actually not stable in the atmosphere of Venus because there's a lot of sulfuric acid, so a constant resupply would be needed to provide this compound, which there is also no explanation for. So there's really no, so there are the absorbers of this spectrum are still unknown to this day, or uncertain, I would say. And here on the right you can see two pictures which are taken 12 minutes apart, and you can already make out quite some differences. So it changes very fast. Now I want to talk about the possible life in Venus's clouds. So first, so in the paper they present temperature, radiation levels, and the presence of water as major limitations for habitability. So, as we already talked about, there are favorable physical conditions for life in some places in the atmosphere at around this 50 kilometers altitude. So there is around 60 degrees Celsius, around 1 atmosphere of pressure, so favorable for life. Then the harmful UV light, which is produced by the sun, is for the most part absorbed by this thick CO2 atmosphere, so it won't be quite as harmful anymore when it reaches this 50 kilometer altitude. Which actually presents a major limitation for life on Venus is the low water abundance in its atmosphere. Here in this paper they argue that this is only a result of remote observation and is not really reliable. So they argue that there could be more water basically in the atmosphere and we just don't know it. So take that as you will, basically. So now to how could this contribute to the spectral features that we talked about before. So they argue that these aerosols in the atmosphere which cause the spectral features could be microorganisms. To kind of give an explanation for this, they compare Venus's albedo to different biotic and abiotic compounds. One which I think is very important, which I want to highlight here, is the iroprotein, which is thought to be involved in iron respiration in some terrestrial bacteria. So here on Earth, it is used in a metabolic pathway, which could be similar to a possible pathway on Venus. And as you can see here, the iroprotein in black or maybe dark violet, and here in red the Venus albedo quite overlap. It also, the spectrum also overlaps with some proteins which are involved in metabolism of sulfur compounds here on Earth, as you can see here. So yeah, and they argue with this that there might be an overlap and a correlation between life on Venus and these spectral features. So now I want to talk about how life could actually survive in Venus's clouds. So As I already mentioned before, these clouds are very sulfur acid enriched, so there's a lot of sulfuric acid present. It's anaerobic, so there's not a lot of there's no oxygen present, and it's CO or carbon dioxide dominated. It also contains a lot of iron, and so they propose this anoxic photosynthetic reduction of carbon dioxide, which they argue could be coupled to an iron and sulfur redox cycle. So basically, they argument that this metabolic pathway uses light as an energy source and is in an anaerobic environment, so with no oxygen involved, or no elementary oxygen involved, and which uses CO2 to create, or carbon dioxide to create more complex carbohydrates, so more complex molecules basically, and also uses iron and sulfur kind of as catalysts. So this light which would be used is they propose a UV flux as an energy source instead of visible light for like plants here on Earth. So now I want to use these species A ferrooxidants as a terrestrial example. So use it as an analog for how life in Venus clouds could exist. So this is a microorganism that actually exists here on Earth, and it thrives at extremely low pH values. So, and I also told you before, in Venus' atmosphere there's a lot of sulfuric acid, so the pH is also very low. So this organism fixes both carbon dioxide and nitrogen gas from the atmosphere, and it obtains its energy from the oxidation of hydrogen, iron, and sulfur compounds. So very similar to this kind of pathway that we have seen here. So it thrives around exactly this temperature range of 50 to 60 degrees under low pH values and anaerobic conditions. So perfect for this 50-kilometer altitude of the Venus's atmosphere. And it actually produces sulfuric acids by oxidizing elemental sulfur. So elemental sulfur gives away an electron and uses, and then Fe3 plus is used as a terminal electron acceptor. So Fe3 plus then accepts basically ultimately the electron, and in this kind of pathway it can produce this sulfuric acid. So in the last part of the kind of habitability of Venus, I want to talk about the transport, or the possible transport from the surface to the clouds. So here they argue that life could actually have evolved on the surface and not in the clouds, and they explain this by that there was actually a habitable climate on Venus's surface for at least 750 million years, with a liquid surface ocean for an estimated 2 billion years. And this liquid surface ocean is supported by the atmospheric deuterium-hydrogen ratios in Venus' atmosphere. So because deuterium is made up of a proton and a neutron, and hydrogen only of a proton, deuterium is way heavier. So when water evaporates, because the hydrogen, which is bound to the oxygen, is way lighter, it can actually escape the atmosphere more easily. So way more deuterium is left behind or in the atmosphere of Venus. And actually hydrogen is way more common than deuterium, but they found more deuterium in the atmosphere than hydrogen. So they proposed that there was actually once a lot of water which evaporated and left the deuterium behind, basically. And in this paper they argue that this is a sufficient time frame for life to evolve, also in comparison to Earth, and that these organisms could have evolved on the planet or on the surface of the planet and then migrated to the clouds. So in comparison to Earth, because Venus's atmosphere could leave nutrients and organisms afloat for long periods, or also here on Earth, they could. There are some microorganisms are found in the upper layers of our atmosphere, but they argue that there could also be this cycle of they basically go further up and basically die off, but constantly, because there's constantly new reproduction in the lower layers, this shouldn't be a problem. So here there's a kind of short overview of what we talked about. Here you can see the metabolic pathway that they propose, where light, or in this case UV flux, the UV flux is used as an energy source, then CO2 is reduced to these more complex molecules, and this iron and sulfur compounds are used to as a catalyst, basically, to create these more complex molecules. Here you can see the albedo of Venus again, and the absorption. Yeah. So, and they propose that these upward winds propel the organisms further into space, and they kind of die off here because of the strong harmful UV light from the sun, which I already mentioned shortly. So in this last part, I want to talk about the future studies and my own personal opinion about the paper. So basically in this paper, they proposed a study focusing on survival of terrestrial organisms under these Venusian cloud conditions. So they proposed that experiments here on Earth where they mimic the atmosphere of Venus and these conditions, where some experiments can be conducted to see if life would survive, or life as we know it would survive. And they also proposed then for in situ analysis, so for future the detection missions or for future missions to Venus, they should also conduct in situ analysis for living organisms and its indicators. So now I come to my personal opinion about the paper. So I think it was more focused on the discussion of the possibilities that is actually possible that there could be life, and less on like an experimental, like a proof kind of, because no actual experiments were conducted. They kind of made a summary, or they gathered a lot of information from different sources and put it together in one study. And I think it shows the importance of considerations and also for hypotheses, because as I mentioned in the beginning of my presentation, I think Venus might get overlooked a lot of times for possible life that could exist there. So I think it's important to think about it, and also consider that there might exist life. And because it's also very close to our home planet, and so I found it really interesting to read about this. So I would highly recommend you check it out yourself if you're interested. And yeah, so my only criticism is with the spectral features, that where they compared the albedo of Venus to some biotic products, that in my personal opinion I found it a bit of a stretch, and not really, I mean, they didn't like say it was proof, but I think the correlation there was a bit of a stretch in my opinion, sometimes at least. And now at the end I want to make a short summary. So what did we talk about in this presentation, or what did I talk about in this presentation? So there's this contrast in the UV spectrum of Venus, and so far there's no sufficient explanation, although it was discovered over 100 years, or no, nearly 100 years ago. And yeah, so in this paper they argued that microorganisms in the lower layers of the Venusian atmosphere could actually explain these differences in albedo. They argue this by also showing that biotic products here on Earth share similar absorption spectra than the one of Venus's atmosphere, or Venus itself. And they also propose these metabolic pathways via redox cycle with iron and sulfur, because there's a lot of iron and sulfur present in the atmosphere of Venus. They also support this theory by showing that here on Earth a lot of microorganisms share, or not a lot, but some microorganisms share a similar metabolism than this proposed metabolic pathway. Yeah. So yeah, that was it from my side. I found it really interesting to read about this topic, so I can highly recommend the paper. And of course, if you have questions, you can ask, or you can, it's uploaded on the YouTube channel, so you can obviously put it in the comments. So thank you very much for listening, and I hope you enjoyed this presentation.